Hello, welcome to our webinar today, our expert session about producing clear aligner, and we'll give you today with our various expert tips and tricks on how to make high quality clear aligner at industrial scale. So the topic we'll cover today is we'll cover all the different steps that you have to go through to manufacture clear aligner. As some of you may know, it's a multi-step process that involves multiple machinery, different processes, and if you want to master the quality of the product you produce, you need to have various decisions involved for each of these steps, but also a clean coordination and cooperation between all the equipment. So from 3D printing, then thermoforming, and then trimming the aligner, and also the global coordination through a software to pilot all this manufacturing process. We will give you some hints on how to get a good control of your quality. So I'm happy to welcome today for the webinar our speaker, Vincent Inkar from Prodways will present the 3D printing. He's a moving light program director. Salvador from Hammer, he's an expert in the thermoforming. Blake from Digital Dental is an aligner specialist and will cover the trimming aspect. And Chris, who is General Manager Healthcare at Oqton, will talk about the manufacturing execution software. So I now let the floor to Vincent.
Good afternoon and morning, everyone, and thank you, Alban, for the introduction. So let me first introduce Prodways Group. We are a French leader and global player in 3D printing and digital design. Our company focuses on the full value chain of 3D printing, being software, machine, materials, or services. Globally, we are now around 500 persons, and at Prodways Tech, we focus on the development of industrial 3D printers. So since around the 1990s, we elaborated our dental industry knowledge through our division Delta in Germany. And we have then developed multiple generations of our moving light large format printers since 2008 with our historical customer driver. Let me talk about some specific about our technology moving light before to jump on those tips and tricks for the aligners. So moving light is a unique approach allowing to combine exceptional X-ray resolution with very high UV power, together with a very large build envelope nicely tailored to fit a full aligner case in average. So that's what you can see here on the right. We can fit around 50 models printed flat on the platform. Our technology allows print times that are as fast as 1 hour in the fastest build time mode available. And the machine was designed specifically to fit industrial needs, now being industry ready with state-of-the-art MES capability through the connection with Oqton suite that we'll disclose in details later. Recently, we released our revolutionary new resin, the Absolute Aligner. You can see a picture here on the top left corner of this slide of an aligner mold printed with this resin. And you can immediately tell one of the main features from this resin is the fact that it has an outstanding ultra smooth finish. This resin was also engineered to have outstanding accuracy, together with some developments to make it automation ready for processes such as OCR scanning or 3D scanning to ensure accuracy measurements. So, all right, that's all you needed to know about our machine and resin concepts. Let's now dive into some technical consideration regarding the aligner mold 3D printing. So you all know 3D printing is involving stacking layers, but it's actually only 1/3 of the size consideration. The key to achieve good accuracy is indeed to use high XY native resolution. Using a native pixel size below 50 micron will ensure you are in the comfort zone for printing highly detailed and accurate parts. I'd like to insist here on the word native because there are many software tricks to virtually increase it, but down the road, what really matters is the size of the tiniest details you can resolve. With our proprietary technology, we can benefit from such high native resolution everywhere on our large format platform, which is a very unique approach instead of enlarging pixel size on other competing technologies. This allows to leverage our large platforms to its full extent, as part can be printed supportless flat on the platform, fitting around 50 of them on the same platform. Having small pixels is unfortunately not sufficient, so it's bringing here to our second idea. Indeed, the 3D objects that we want to print have the oh, sorry, I skipped and confused my message. So let's talk about the z-axis now. The layer thickness is the #1 artifact creator into all 3D printers. The lines on the molds will induce lines on the liners. That's actually very qualitative, as with our high XY resolution, we are able to reach market standard accuracy requirements, even at high layer thickness. So naturally, reducing the layer thickness will reduce visible layer lines, but there are actually a few tricks. When giving it a closer look, my recommendation is that actually below 75 microns won't improve much, except maybe on the buccal side, which we have to recognize is not the most visible one when you are talking to each other. On the opposite, beyond 175 microns, layers will be strongly visible, and this would compete against the need for high resolution that I was just explaining a few minutes ago. Because manufacturing speed is directly correlated to layer thickness, the selection of appropriate setting is a key process consideration. In order to save as much time as possible, our machines accommodate adaptive layer thickness printing, where larger layer thicknesses will be used into the gingival sacrificial portion, where the resolution is not the key concern. Third idea, after printing into a liquid resin batch, the part needs to be cleaned to remove the excess resin. This can be achieved either by cleaning solvent used, let's say that's the traditional way, or by means of a mechanical action. You all know the use of IPA is very standard into the 3D printing. It works very well, in particular when needing to clean very complex and intricate geometries. On the other side, it will increase the layer visibility. So regarding the aligners now, we tend to prefer better optimized solution. The use of a spinning machine will allow very fast cleaning without using any solvent, while giving you the ability to recollect the resin for reuse directly into the printers. Additionally, this will allow to get smoother surface, in particular when used in combination with our absolute aligner resin. So you can see a picture on the right of our spinning machine. That's typically the machine that we are using in combination with our blue resin to produce parts such as the one we were showing you on the previous slide. I forgot one idea about XY resolution that's very important. It's a bit technical, but I'll explain it to you. As I said, we have high native resolution, but that's not enough. When we are printing a 3D object, well, in the nature, any object has the tendency to have curves. And printing a curve with perfect square pixel is not that easy because it requires a point-to-point alignment of square pixels, and that will reveal a staircase effect if you do nothing. In video gaming, they call that jaggies. So to solve that, we are using advanced slicing algorithm of our own. We are computing the images into a higher resolution where the virtual pixel size is way below 10 microns. Superimposing such a high resolution of the cross section we want to print allows a better accuracy into pixel rendering, because we are then able to light each pixel with optimized energy dose as we are shrinking down from high to low resolution. That's called a super resolution. We actually did a presentation a while ago on that topic, and you can request it at the end, and we'll share it with you if you're curious. And this feature is coming by default with our machine software, allowing to smoothen out the traditional DLP related artifacts. Finally, and maybe most importantly, an important trick is to, not a trick, but general practice is to make sure the full workflow complies with medical device certification needs, following the operating instructions provided by your suppliers together with quality assurance methods like 3D scanning. So that's it for the 3D printing and post-processing aligner mold tricks. Let's now jump to the first step of the real aligner manufacturing. And for that, I'll give the floor to Salvador that will explain to you all about thermoforming.
So the first big difference we may find is that with our machines, you can thermoform between 100 to 1,200 units per hour, which is much higher output than what our customers can get with the manual machines. This is an important part, but we are also supplying a type of a machine that can put all together a lot of different pieces of equipment that currently our customers and potential customers have, and we can put them all together so they are no longer a separate part of the process and they require one operator each one, such as vision system or the laser marking. So for the vision system, we have integrated in our solution camera systems that can read the 3D or the OCR code that you are 3D printing on the printers and can track that information and transfer this to our PLC so we can keep communication with the MAS system. And thanks to this, we can know exactly where is each aligner, in what part of the process is, and we can communicate with all the rest of systems in the workflow, whether if it's the printing, whether if it's trimming, or with the MAS system. Okay, the laser marking does the same. So at the entrance of our machine, you get the recognition of the code, and then we thermoform, we trim, so we punch it, and then we transfer that to the laser marking. So you have laser marked already the code that is identifying that model at the end of our system. So the model from beginning to end will be controlled by this. The third main point is that the material will be thermoformed by means of a roll. So the material will come in rolls instead of pre-cut discs, which is really a big advantage for our partners, as long as it may allow to get a discount on the price up to 50%. Okay, because most of the suppliers of the film, they are anyway extruding the material, but if they are serving pre-cut discs, they have to cut it, to punch it, and to pack it before sending it to our customers. The other point that we want to highlight is the flexibility that we've got in the system. It's not like a manual machine in which you are going to have one machine and you can only use several types of material that have preset recipes for them. We have a modular system, and in particular the heating system that I will explain later can allow you to set up more than 100 different materials. It does not matter just if it's a different in width, in thickness, if our customers want to have a protective layer on one side, on the other side, or if they just run different materials. And the fifth point we want to highlight is the improvement that we have got on the thermoforming process by means of a 10 bar pressure increase, what means that the resolution and the thermoforming of the aligner will be always better than the result that you can get on the manual machines. So if we go to the next slide, we will have our focus on three of the main parts just quickly, so we can understand what are the main features that we can offer. So I don't know if we can go to the next slide. Perfect. So here we have divided three of the main advantages. The first of them is the temperature control, which is really essential. As I was referring to, we've got a heater that is divided in several areas. So we are able to set from the recipe, so just by means of the screen, to set different temperatures for each of the areas of the heater and that we want to heat on the film. So if our customers are using one material or another, all what they have to do to switch from one to another is to switch the recipe on the screen. The different areas will put more heat or less heat on each of the areas, and we'll be able to heat it up slowly or quickly, depending on the material requirements. The next point on the control is the thermoforming. And apart from having 10 bar pressure, we are controlling by means of a sensor what is the surface temperature of the film when the film is getting into the thermoforming position. So with this, what we are making sure is that you are always thermoforming with the same result. Usually in manual machines, we may have the problem that the machine is preheating or some components are preheating, and you may get different results when you thermoform for 20 minutes and when you are 3 hours thermoforming. With the machine, we are regulating the heat and we are controlling and making sure that we are thermoforming always at the right temperature. The second point is the scalability of the solution, and we want to make sure that we are offering a turnkey basic solution, which is the TP12 or TP25, but we can go farther from there. So it's also possible for us to automate all the feeding of the parts into our machine. In fact, already with a basic machine, both TP12 and TP25 can be operated only by one operator. But it's even more, it's even possible to have automatic transfer from the printers to our machines. So then we don't need the operator loading the models, and from our machine to the trimmers. So we can add robotics, we can add different systems, thing that we are doing already, to modify the machine, to get the models into the machine directly from the workflow on the 3D printers. And once the models have been laser marked, we can transfer them to the trimming machines as well. The third point we want to highlight is the interoperability, which is really essential in our process. And by building this kind of workflow in which we are working together with Prodways, with Digital Dental, with Oqton, we are making sure that, you know, all the 3D printing quality, it's getting into our machine, and that we are able to read the codes, because the quality and the control on the system that Prodways has, it's enough for the system to identify up to 98% of the parts that are getting into our system. And we are also making sure that the fixture, the datum, and all these kind of mechanical and software things that we need to make sure that everybody is controlling and that work together are controlled. So when the parts are getting out of our machine and getting into the trimming machine, they will work perfectly as well, with regards to tolerances, to quality, to time, etc. So finally, all the system I explained, it's controlled by our PLC, and all the information is transferred to the MAS of the customer. So we can be in real time informing the customer and the system on what's the result of everything. Thank you very much.
Thanks, Alva. Great presentation. So one of the first questions I want to address is, why should we automate our trimming? So at this point, we've covered a great way to 3D print, a fantastic way to adapt your thermoforming to high volume needs. But what I really want to cover is the decision between hand trimming and your automated trimming. And for that, I see three primary reasons. The first would be scalable growth. When you hand trim, which is what I'll refer to as the traditional method, you have the possibility, or you open up the door to inconsistencies or mistakes. If you've ever trimmed on a liner, you know that a quick flick of the wrist can ruin or cause for a remake the entire stage. The next point to automate your trimming would be to empower the clinicians to define the trim lines. So depending on the workflow, it's possible that we are giving up the control of the trim line or the decisions behind the trim line to a technician that didn't actually plan the case. When you automate the trimming, you actually put that control back in the power of the clinician or the design team, those that are actually making the clinical decisions on how to move the teeth. And the third and potentially most important reason would be to save time and money. When you hand trim, the only way to scale is to employ more hand trimmers, and that process takes time. So when you automate your trimming, you actually unlock a faster trim, which means that your employees can now do more trimming per day or per shift. And the operation of operating a trimming machine, such as the digital dental machine, is actually easier. So you reduce your onboarding and your training costs. On the next slide, I'll go into why digital dental solution is so competitive in the market. So when we talk about these different labor wages or the time involved in trimming aligners, one of the things we have to always think about is how much money is going to be saved when we switch from manual trimming. And from the wages that I've heard in the past and the calculations we've done with the time savings, it's about a 40% savings compared to manual trimming. And when you take that into account, it's about a 9-month ROI for a system such as ours. The next would be unlimited scale and capacity. The other benefit to trimming is that you can trim 100 aligners an hour. And the other, as we've seen over the last 18, 19 months, is uptime is extremely important to an operation. And as you may be able to well guess, trimming machines don't call into office with a cold or a fever, so there is the benefit of phenomenal uptime. The unique thing about Digital Dental is that we provide global service and support. We have experienced technicians in the United States, as well as an experienced team in Malaysia. So when you work with a company such as us, you have that benefit of having 24/7 support. Finally, one of the points I wanted to touch on was the industrial grade cam. So in the process of trimming clear aligners, it's really important that you pick a high quality treatment planning solution. We are preferred partners of 3Shape, but we also work with others in the market. And the benefit of these treatment planning softwares is that you obtain not only the ability to fixture your models as you see here in the photo, but you also unlock that ability to generate those trim lines as we discussed earlier. Now, that being said, treatment planning softwares don't run trimming machines. It's important to have an intermediate process called CAM, or computer aided manufacturing. And Digital Dental has actually placed all of that process in the cloud. So switching from a manual process to a digital process is extremely easy because you take these files from your treatment planning service or from your treatment planning software, you upload them to the cloud, and Digital Dental will do a variety of things, including error checking and collision checking to make sure that all of the aligners are successful. At this point in the process, it would be very expensive to have a mistake in the trimming, whether that's manual or automated, and it could result in going all the way back to the 3D printing stage. So when you automate these trimming features, these trimming functions, excuse me, and you can error check them in advance, you actually save money on both your labor, your time, but also your resin and thermoforming, because when you can ensure that the product that you trim is not only up to your clinician's specs, exactly how you want, but also error-free, you save time and money throughout the process, and you can immediately move on to the next step. So we're going to go over some questions here after Chris's presentation, but I'd like to give it up to Chris over at Oqton so that he can explain his MES system.
All right, thank you, Blake, and hello, everyone. The manufacturing of aligners can be somewhat of a logistical challenge. The production process involves many similar parts per patient. They require a lot of unique preparation work, yet it's a bit repetitive in nature. So a good software is needed to manage and automate the process. And that is where Oqton comes in as an operating system for aligner manufacturing. So using Oqton as a manufacturing operating system, you will be able to quickly realize a number of benefits, and the key ones are here listed below as tips and tricks. The first and foremost tip really is to have Oqton automate all your 3D print work preparation. So we're talking about file fixing, file orientation, automated labeling, automated hollowing, automated support calculation, and automated nesting on the printer platforms. And doing so, you can save money on manpower, and you can have your dental technicians that are nowadays so difficult to find and focus on more meaningful projects than on repetitive tasks. As a second tip, you can use Oqton to automatically prepare nests for your machine park, following your own logistical rules. For instance, you might not want to split a patient order over multiple machines. Then you can define this and you have it prepared in an automated way. And doing so, the automation will increase your efficiency. And why would you not go cloud-based with your software? This modern technology will allow easy file sharing across different entities. If you have the size that you have different entities, but otherwise it will allow you to easily store files. You'll benefit from parallel cloud computing, which will make sure that the time to prepare 1,000 files will not be that much different from the time to prepare 100 files, and you will have automatic and safe backup procedures. And why not use the Internet of Things, which is another modern technology available in Oqton for your machine monitoring and connectivity. This will give you alerts to anticipate and prevent machine issues, and it will make it easy to launch a next print in time. So with Oqton, you can drastically simplify your suite of production software as well. As Oqton works for all 3D printing printers, CNC machines used in dental, hybrid combinations thereof. It can also replace your MES software for scheduling and planning, and perhaps you're still using a spreadsheet for that. And it can replace any machine monitoring software solution you might already have. So all in one software, making it very easy. And lastly, through the use of dynamic QR code travelers or the digital equivalent of an NFC card that travel with your parts, Oqton can allow you to go entirely paperless. Next slide, please. Through a deep integration of Oqton with the different partners in the ecosystem, a number of unique benefits are realized on top. For instance, an automated hollowing function in Oqton that is made compatible with the centrifuge cleaning process that Vincent already described in the beginning, via the creation of via the automatic creation of drainage holes. You can do compatible hollowing that will allow you to save 15 and up to 20% on resin, which is very, very significant. Secondly, when automatically nesting parts on the platforms of a Prodways machine, Oqton will minimize the travel of the machine projector. So when a platform is partially filled, Oqton will first fill the parts on the platform that correspond to the rest position of the projector, so it doesn't have to move and time is saved. And similarly, when the platform is already filled, it will place all the high parts, or it will place the highest parts in the rest position of the detector, so that you can benefit from the fastest build speed. And lastly, through a deep integration with the different partners you heard today, Prodways, Hamer, Digital Dental, and through the use of IoT, Oqton is able to automatically document every step in the manufacturing process, giving you the full traceability of material batches, part status, part history, rework history, and so on. And this concludes the advantages of working with Oqton. And I will hand it over to the Prodways team again to conclude with the benefits of an open ecosystem.
Thank you, Chris, for the presentation, and thank you to all of you for giving details and a view on how the system operates and how to make them work well all together. And I think that's also a conclusion of this presentation, because even if you need to get optimization on each of your steps, and there is a lot of knobs and tricks that are put under control by the company that are presenting their product here, there's also an important step to have a good coordination between all the actors, because when you are manufacturing a large volume of aligner, you're probably also experiencing a large business growth with a lot of challenge as you continue to expand, and you don't want the solution that you're using to bring you problem, but to bring you solution. And so it's with a great success that we've been able to interconnect and have all this equipment operate together, so that it gives you a seamless experience and improve your production capacity, delivers you the best quality while maintaining room for improvement and progress as you need more and more capacity. So thank you to all the speakers. We'll now move into the questions. So if you have any question, you can drop them in the chat or in the question section of the webinar. And we'll take some of the questions. Okay, there is a first question, I think more for you, Vincent. There is a question about the precision and accuracy with the centrifuge cleaning.
if there is an impact on this process?
So there is an impact if you do nothing. So it's all the same. It's always the same story. It's a question of process engineering. So what we do with the spinning machine is that we adapt the scale and accuracy settings that we have into the machine, that when combined with the proper speed into the spinning machine, the proper cycle time, we can get the proper accuracy. So actually we developed the resin so that it's allowing extremely accurate printing, and we developed a recipe, like Hammer is calling it. We call it the build style at Prodways, but we ensure that we can get the needed accuracy for aligner manufacturing. Frequently, we hear about 80% of the scan data point within plus minus 100 microns. And this is something that we can get easily, no matter what the layer thickness or build style combination that we are using in the process.
Thank you, Vincent. Another question more for you, Blake. Do the finished parts require polishing after the trimming?
Yeah, so that's a great question. And one of the things that we do at Digital Dental to prove that question, or prove the answer to that question, is actually take your 3D printed parts with a fixture and a trim line and trim them up for each of our groups. And through that process, we like to prove that the cut quality is phenomenal. We typically examine our cuts through a 100x microscope and take digital photos of the results there. And everything that we've found from our latest and greatest milling strategies says to us that it is a phenomenal trim. Now, being a medical product, we do like to have that reviewed by the clinician, and we do respect their decision to do so. And the other facet to this question is the accumulation of 3D printing resin, plastic, and cutting tools that we use. That recipe of manufacturing can have variable cut quality. In the process that we've laid out today with the Prodways 3D printing resin, with Hammer's high quality thermoform, and with our latest feeds and speeds, we found that the cut quality performs very, very well from a microscopic view, and we would be happy to share those photos with you.
Thank you, Blake. A question more for you, Chris, around the coordination and the Oqton software. You mentioned using artificial intelligence, AI, in the process. I mean, how is it used, and does it mean that the software will automatically improve?
Yeah, that's an interesting question. So yes, there's a lot of AI used in Oqton. It's used in many layers of the software. The first time it's used is when you upload files, and then just from the shape of the file, an AI model is used to determine which type of file it is and which specific flow to use, because Oqton is configured to support automation for different production flows. There's aligner flows, but it can also be metal printing or CNC machining of crowns and ridges, and it will recognize from the file shape what you want to do and then apply the correct flow. So that is one AI model. Another is used for orientation, where per file type we have a large AI model that defines the most suitable orientation. But there's also a self-learning model built in. If you want to tweak that orientation, then the software will learn how you manipulate it and propose the orientation going forward in this way. So this way you can benefit from the general database and then tweak it just for yourself and your own use within your production environment if you want to make change. The same even for placing pins for CNC work, where there's also a general model based on logical rules, and where you can adapt as a user and bring in your preferences that are picked up by the software. So these are some examples of how AI is used in.
Thank you, Chris. There is another question also about the impact of the treatment planning and how do you define the aligner. Maybe Blake, you want to take this one?
Yeah, I'd be happy to. So it's a really good question, because when you are picking your treatment planning software, in some ways you're actually picking your downstream partners. So we've worked with a variety of treatment planning softwares. I would argue that most lab-based softwares around the world now have the ability to add a fixture and generate a trim line. So it's actually within that software that you generate both of those, and by fixturing each of your parts, as well as generating a trim line or doing some other things such as identifying parts for laser marking, you can then automate the rest of the system. Alvin, did that answer the question well, or should I elaborate?
No, that's good. Thank you very much, Blake. I think we have time for one or two more questions. There is a question for you, Vincent, about what's the most important factor to get clear aligners on the 3D printing?
Well, there are many factors that may influence the clarity. Maybe we can discuss together with Hammer on the brand of the foil, but there are different order of magnitude. I would say that the most important one is the combination of first the material, the printing material for the 3D printed molds, together with the spinning process. How to clean the part is very important, because as we were explaining, if you use IPA, well, you remove all the resin from the intricacies into the staircases from the layer thickness. When you are using the spinning machine, and it's not just spinning parts, there is a lot of application engineering behind, combined with specific material, because it's not working with any of them. That's how you can get the very clear aligners and with no lines aligners. Finally, you also have to choose correct layer thickness, because if you are printing 300 micron layer thickness, you will have issues to blend them in even with the spinning machine. So to summarize, I would say resin, cleaning, recipe into the machine, and lastly the foils. But here it's more a medical question, and we differ that on the customer side to choose, and we try to accommodate anyone.
Thank you, Vincent. Question for you, Chris. Actually, two questions, so I'll drop them to you in a row. Is Oqton compatible with other 3D printers? And also the question, can you re-elaborate on the printing time optimization? And maybe Vincent, you can complement, because explaining the link between how you optimize the nesting and the printing time.
Yeah, absolutely. So yeah, Oqton is agnostic software, as we call it. We believe most in one software for everything, and making it easy for the user. So yes, it is compatible with other printers, because we know a typical situation is that there's a mix of different brands and technologies. So yes, we do that. And the part on the second part of the question on specific integration, which is of course not with every brand we have the same deep integration as with Prodways, for instance, where we do work together in an excellent way. And there we have done a number of things, as I was explaining in the presentation. So the way parts are nested, the travel of the projector is minimized, so this gives optimum speed. But we have done more. We have also integrated IoT. So in Oqton we have a dashboard where you see everything that's going on in the machine, including live camera feed. So you know what's going on. We can also directly send to the machine, and very soon we will be able to even, that's the last part we're rolling out, to launch the machine from within Oqton, to make it all very easy going forward. And yeah, there's even there's a lot more to come. Also for troubleshooting, even if things go wrong, it's very practical also that the engineers in consent with the customer, obviously, but can use the cloud aspect to immediately look in the build file what happened, what settings were used. It really makes the communication easy, and it helps to keep a very short cycle for shooting. So these are just some things that come to mind that really help the customer and show how deeply we are integrated.
Thank you, Chris. A question for you, Salva. Sorry, I lost the list of questions. Yes, what kind of material and brand can you process in the thermoforming machine?
Okay, thank you for it's really a good question. Basically, I'd say as a first statement that everything that can be thermoformed on manual machines can be thermoformed on our machines with better results. What we do see in the market is that there is like a common trend to go or to monolayer materials or to 3-layer complex materials. On that sense, we have built several partnerships with several players in the aligner world. So there are like 3-layer materials like Zendura, FLX, okay, like Bay materials, like Goodfit and others. And then there are other materials as well that they are more for the polyurethane-based resin or just PTG resin, okay? And both of them can have like an additional mask or protective layer on one side or two. But I'd say that every material that can be thermoformed on a metal machine can be thermoformed in our machines, with the advantage that you can choose different widths, different thickness, different protective layers. And there are like 2 different types: the mono materials that will go for PU, polyurethane, and PTG, and the 3-layer materials like several others that are there in the market that have been validated, and several more brands are right now being validated in our machines. So for our customers, all what they have to do to switch from one to another is to switch the recipe on the screen, and the heating parameters will get adapted to the right material.
Thank you, Salvador, for the answer. We have more questions, but unfortunately we are running out of time. We will forward your question to each speaker because some of the questions were addressed to some of us. I would like to thank all the partners participating today, Hammer, Digital, Dental, and Oqton, presenting their solution. We'll post a replay, we'll forward the question, and you can reach all of us very easily. And thank you to all the participants, and apologize for the few glitches during the presentation, but we got it under control. Thank you, everyone, and have a very good day.
Thank you.
Thank you.
Bye.
Thank you. Bye.